Now, so here we go. Here's question number 5. And so we're starting with a velocity statement. So it's always worth just highlighting actually the information that we've got. We're told the catapult is 20 meters up. So, and we'll just start each particular problem. As I've usually done, is let's start with S, V, A. Remember, we differentiate down, anti-differentiate back up. So we're asked to find the velocity after 3.5 seconds. So we'll do that. That's just so A really is just a straight substitution into the equation, and that's equal to 180 minus 10 times 3.5, and we do that and we find that's 145, and what are we dealing with? Meters per second. So that one should have been okay, straight substitution into the equation. And now we need to calculate when the stone is momentarily at rest. Well, when it's momentarily at rest, we've got the velocity is equal to 0. So we've got the velocity equation, which is 180 minus 10t, and we set that equal to 0, and we find out when that equation is momentarily at rest. So adding 10t to both sides, then dividing by 10, and we find that the velocity, or at least the stone, is momentarily at rest after 18 seconds. C, we would like to know what the acceleration is. So we've got there 180, the velocity is 180 minus 10t, and therefore if we differentiate that, the answer is -10. So, and that means it's always -10. So notice that the t disappeared, and that's important to realize that. That means throughout the whole stone going up and down, the acceleration is -10. So it's continually decelerating. So it'll reach the top, it'll stop, and then it will fall back down to the earth with an acceleration of -10, and the unit is meters per second squared, or meters per second per second. D says the times for which the stone is moving in an upward direction. So might do that just off into the right. Oh, we'll carry on down. The stone is moving in an upward direction. So what it does is that the stone goes up, okay, it comes to rest momentarily, and then descends down again. And so we know that at 18 seconds, right up the top there, it's momentarily at rest. So the question asks, if we go back to it, the times for which the stone is moving in an upward direction. Well, you would assume that it's moving in an upward direction as soon as it's released, up until the time that it gets to where it's momentarily at rest at the top of its path. And so the answer to that, the times, okay, then we would write that in this way. We would say t is more than 0, but is less than 18. So that's when it's moving in an upward direction. Okay, remember when it's 0, notice that it's just less than, not less than and equal in both of those. Because at 18 seconds, it's not moving upward, it stopped. And at 0, it's not moving upwards, it stopped as well. But between those is where it's moving in an upward direction. E, the height of the stone above the ground after 5 seconds. So we've got a velocity statement again, which is 180 minus 10t. Now, if we look back over here, you can see that we have got velocity and we need to get to S. So we're anti-differentiating. So therefore S, oops, back to that one. S, therefore, anti-differential of that is 180t minus 10t squared over 2 plus C. Okay, so the C we need to work out. We'll just tidy this up though. That's minus 5t squared plus C. Now we are told that the catapult is 20 meters high. So you would assume, therefore, that if we're measuring the height above the ground, which we are, then at t equals 0, the height which we can use. The height is equal to 20. Is that what it was? 20? Yep, 20 meters. All right. So that's handy. So substituting all of that in, 20 is equal to 0 minus 0 plus c. C is equal to 20. And the equation for the height, you can use either h or s, is equal to 180t minus 5t squared plus 20. And last question is the distance through which the stone falls in the 25th second. Okay, so in the 25th second, so what we can work out what is the distance after 25 seconds, what is the distance after 24 seconds, subtract one from the other, and we get the distance in the 25th second. So remember that when it's got like 25th second, we're actually talking about 1 second, okay? And it just happens to be at that time, from the end of the 24th to the end of the 25th. So if we substitute 25 into here, so which we get 180 times 25 minus 5 times 25 squared plus 20, we work that out, 180 times 25 minus 5 times 25 squared plus 20, and we get a figure of 1395. Then we do the same thing for 24. That's 24. And we work out what that's equal to. So 180 times 24 plus minus 5 times 24 squared plus 20, and we get a distance of 1460. Okay. So you can see it's on its way down, which it would be. All right, so it's on its way down, and it's just the difference between these two. So 1460 minus 1395, and you get, it should be 65. So we get the 25th second. It falls through a distance of 65 meters. All of the answers are meters. Done. That's not.